This video goes through some of the problems on the 5.4 problems page. One thing we have to be careful about is to be able to convert degree minute seconds into decimal degrees. So let's look at number 8. It says each base angle of an isosceles triangle measures 55 degrees and 30 minutes. Let me zoom in a little bit. So with the 55-30 minutes, I have to think about that as a decimal. I have to change it to a decimal. That's 55 and 30 sixtieths. 30 over 60 is 0.5. So 55.5 degrees is the decimal degrees. It tells us that we have an isosceles triangle, and that's the base angle measurement. So we want to sketch an isosceles triangle. Each one of these angles is 55.5 degrees, and it wants us to find the altitude of the triangle. So if we sketch the altitude in here, the altitude's an opposite side. And each of the congruent sides is 10 centimeters long. So that gives us a triangle that we can use. We don't know what the altitude is. We'll call that y. If each of the congruent sides is 10 centimeters long, that actually is the hypotenuse, and the base, or the base angle, is 55.5. This gives us a sine problem. Sine 55.5 is equal to y over 10, or 10 times the sine of 55.5 is going to be y. So that's how we find, is going to be y. That's how we find the altitude. To find the base, we call the base x. That's an adjacent with the hypotenuse. That's going to be a cosine. And remember that when we find x, the actual base of the triangle is 2x, so we have to double that to find the answer that they're looking for part B. And then they want us to find the area of the triangle. We could do the base times the height times a half to get one triangle, and the base times the height times a half to get the other triangle, or basically the area of the triangle is going to be base times height. So that's how you would do part C. Let's look at one of these word problems. Let's look at number 9, the boating problem. So this Ponce de Leon lighthouse is the second tallest brick tower in the United States. It was built in 1887. That's all extra information. It's 175 feet above sea level. How far from the shore is a motorboat if the angle of depression from the top of the lighthouse is 13 degrees 15 minutes? So here, again, we have to worry about having decimal degrees to more easily use the calculator. So we have to think about 13 and 15 sixtieths, which is a quarter. So 13.25 degrees is the decimal degree equivalence of 13 degrees 15 minutes. So I think we have enough to draw our triangle. The lighthouse is 175 feet high. The angle of depression down to a motorboat is 13.25 degrees. And how far from the shore is the motorboat? Okay, make sure we have it all here. They're telling us that we have a 175 foot tall lighthouse. We're assuming it's on the edge of the shore, because they don't tell us different. It's somebody in the lighthouse is looking down at the boat at a 13.25 degree angle of depression, and we need to find out what x is. So this angle of depression is exactly the same as an angle of elevation from the boat up towards the lighthouse, which gives us an angle inside the triangle of 13.25. And we have a tangent problem. Tan 13.25 is equal to opposite, which is 175, over x. X is in the bottom, so we swap places. X is going to be 175 divided by tan 13.25. So bring the calculator out. 175 divided by 13.25 tangent equals 743.19. And before doesn't say anything to do with rounding, so I would think that since we're talking about 175 feet, basically we're talking about 743 feet. So the boat must be 700 and, I don't know why I put 54, 743 feet from the lighthouse. Okay, maybe one more here. Let's look at 26. Okay, so a plane begins they're giving us a diagram to go with this one. A plane begins its descent to the airport. It's 3,900 feet from the ground, so there's a 3,900 for the altitude. Its angle of descent is 6 degrees, so from the horizontal, this is the angle of descent. It's just like an angle of depression, which means that this angle of elevation from the airport to the plane is also going to be 6. And they want us to find the ground distance from the airport. We'll call that x. And also, how far must the plane fly? I take that to be the hypotenuse. That's the path it's going to fly along. We'll call that w. So let me redraw that triangle and label it. So w is going to be the length that the plane flies. X is the distance from the airport. It's 3,900 feet high. And there's a 6 degree angle from the airport to the plane. And using 6 as our reference angle then, if we want to find x, we have an opposite over adjacent. That's going to be a tangent problem. Tan 6 is equal to 3,900 over x. Swap places. X is going to be 3,900 divided by tan 6. If we want to find w, which is the hypotenuse length, using 6 as our reference angle, 3,900 is an opposite, w is a hypotenuse, so we could say that's a sine problem. Sine 6 is going to be 3,900 over w. Again, the variable's in the denominator, so we swap places. W is going to be 3,900 divided by sine 6. And so I'll leave that for you to finish on the calculator. This goes with B. This goes with A. And they're not saying anything about rounding or anything like that. So since we're talking about 3,900 feet there, that's 2 significant digits. I would think that we're just basically going to round off to a whole number for that one. We might have time for one on the opposite side here. Let me turn this over. Now, this mid-chapter quiz is a separate set of problems. I can help you individually on those if you have questions. That's a separate page in the Canvas modules. Let's look at one of these. We'll talk briefly about 30. We won't do it. But notice that they're trying to figure out how tall the building is, and they know the height of the flagpole. So if you let the building, say, be Y, the small triangle, you have a Y for the height of the building with this 54 degree, 54 minutes. So again, on 54 degrees, 54 minutes, you actually have to do 54/60ths and turn that into a decimal. Same thing over here, 4730 is going to be a 47.5. For the larger triangle, you're going to have Y plus 40 for the side length, because you're all the way up to the top of the flagpole. For the smaller triangle, which uses the 47.5 degree angle, you've actually just got Y for the opposite side. Basically, I think you need to set up the problem for each one of these and then solve for Y. Set Y equal to itself and solve for Y. Okay, so that's enough for that one for right now. Let's talk about number 29. Latasha and Markeisha are flying kites. Latasha's released 250 feet of string. Markeisha has released 225 feet of string. Latasha's kite makes an angle with the horizontal angle of elevation of 35. Markeisha's kite makes an angle of elevation of 42 degrees. Which kite is higher and by how much? So we have two separate problems we need to solve for this one. If we talk about Latasha's kite, let's see, she's released 250 feet of string. That's the hypotenuse. Here we have the kite. The angle that the string makes with the horizontal, which is angle of elevation, for Latasha is 35 degrees. And we can figure out how high the kite is. We've got an opposite over hypotenuse that's going to be a sine problem. Let's look at Markeisha's. So for Markeisha's kite, she's played out 225 feet of string. We'll call her kite Z for its height. The angle that her string makes with the ground is 42 degrees. And we have another sine problem for her. So we solve both those sine problems. Latasha's is going to be sine 35 is equal to Y over 250. Markeisha's is going to be sine 42 is equal to Z over 22.5. You're going to be able to solve for the Y and for the Z, and need to find out which number is bigger. That's going to be whose kite is higher, and then find the difference of Y and Z, or Z and Y, and that's going to be the by how much part. So I'll leave that for you to finish up. 31 and 32 are just mixed review problems. So let me know if you have any problems with these, or bring this up when we have our Google meeting and we can go over any details that you have questions on.